If you go here on our Canvas page to where it says Final Exam, it looks almost identical to what I put together for you guys for both Test 2 and Test 3. That's not a coincidence. I literally copied and pasted and changed some of the words. Okay. So the first thing is the technology requirements. If you took Test 2 and or Test 3, I'm assuming most of you took both of it because I think most of us did. This is the same thing of you need to make sure you have that Respondus thing set up on whatever device you're going to be using. In terms of a practice final exam, there's a couple things missing right here. One of the things that is not missing is the actual study guide. This has been up. You guys were actually the first study guide for the final exam that went up. I think it's been about a week, 10 days, something like that. It's been a little while. Could have also only been 3 days with how things have been going. So once we talk about the study guide for today, or the study guide for the final exam today, I'll go ahead and put the updated version right here as well, so you'll be able to grab all of the comments that get written. Okay. I don't yet have the practice final exam finished for you guys and ready to be played around with. Once I do, I'll put the link right here. And one of the things that I am in the middle of doing and did not get done before for today is I'm reopening all of our old practice test, and I'm also going to make it so you can see your Test 2 and your Test 3 to see what you got right, what you got wrong. The practice test and Test 2 should be accessible later today. Test 3, you're not going to be able to access that one until after I go through it and make sure that Canvas graded everything correctly. Okay, so you should see that one. I'm hoping to actually do that probably tomorrow with the way things are currently going. So you should be able to access Test 3 either late tomorrow or worst case scenario, May 1st. And if for some reason you can't access either the real Test 2 or Test 3, feel free to reach out to me. I've been having a little bit of issues with the settings to make sure you guys can get access to the past real tests. The practice ones are easy to do, but the real ones have a little bit of a funky setting I have to change. Update, if you do have any questions, either when you're studying for the final exam or specifically on any of these practice quizzes that you can look at or practice exams, either this one or the previous ones that I'll get you the links all together right here as well after this time together. Feel free to contact me. You can contact me in a variety of ways. Email's fine. I pretty much always have my email set up and so I can see when an email comes in. You can also contact me via Discord. It is set up on for our course, although I don't think any of you have used it so far other than seeing that it's there for a couple of you. And I did just this afternoon go ahead and set up a couple of extra office hours. And just so you can see it, you go to the WebEx setting, and I don't know how closely your guys' look to this or not, because sometimes student versus instructor looks different on Canvas. The thing you want to look for is you'll want to look for where it says appointment booking right here. And this is mainly for questions that you wouldn't want anybody else to know about, like questions on grades, etc. So here you can go ahead and it's going to look different on yours. Mine has an offer slots. Yours should probably say something like select a slot or whatever the actual term is, and then you could go in and select a time. And that would be an individual time if you want to talk to me. Okay. So that would be that background information. Now, in terms of the actual final exam, this is exactly what you would have seen in terms of Test 2 and or Test 3. I've got a spot here specifically for scratch work. So if you've got anything you want me to see from any of your problems, especially some of the differential equations problems where you're working through them and you try to put them into Canvas and maybe you're like, you know what, I just don't see how to enter this answer correctly into Canvas. Maybe this is a place where you say, hey, you know what, let me go ahead and upload that guy. Whatever you want to upload is perfectly fine. And what I'll do when I go back to check to see if Canvas grades questions correctly is I'll actually have your scratch work pulled up next to me, and actually it's a separate window normally, and see if there's anything I need to worry about there. Once the final exam is ready to go, I'll put a button right here similar to the ones that have said Test 2 or Test 3 for a prior test. It'll probably say something like final or final exam. Click on that and it'll take you directly to the final exam. You don't have to wade through anything else. But you'll also be able to find the final exam other places, such as through the syllabus or also on your, what's it called, your to-do list, your upcoming things. your assignments list, your calendar, whatever it is that you're looking for other things that are due. So here are some of the nitty-gritty technical details. I'm going to give you 3 hours to complete the test. That's assuming maybe you got, if we were in class, that you got there early and we started a little early, and if I let you go overtime a little bit at the end. Okay, so it's like grabbing the 15 minutes before and after our official start time. Now, I am assuming that nobody actually has 3 final exams next to each other, so if you actually do want to start early, you can, and I went ahead and our final exam is going to start to be open at 12:30. That is, I'm double checking the time here, that is an hour and a half before our official start time. So if you just want to start early, totally fine. I also have it still open all the way until 6 p.m., which is an hour and a half after our original start time. So it's split early, late. So if you do have another final exam that's scheduled to be right next to ours, you don't have to worry, I've put in extra time there. Just like with our other online tests, you're going to have 2 attempts, and while I've created those 2 attempts on purpose, so if you have any sort of issue like you have your internet goes down or you have a glitch and you get kicked out of Canvas, that's okay, just grab your second attempt. Although you have 2 attempts, you're not going to have to tell me why you took the second attempt. So if you also just get a score you don't like and you want to take it again, that's also totally fine. And this is almost enough time to do 2 of those guys back to back. To be fair, I wouldn't recommend doing that just because I wouldn't want to do 6 hours of a final exam. Okay? But I've got the option so that you can do basically whatever you want. At the beginning of the final exam, just like with our other 2 tests, I'll have a list of how to write the various things that you would need to enter, and I'll go ahead and update this if needed, but this is the basics that we've had all the way from test 2. Okay? And test 3, all of our independent variables were t's. In the final exam, you'll probably see independent variables that are both t's and x's. This one here is actually the copy and paste from test 2. Okay? But that's what there is in terms of the technical details. Got your actual test button will come here soon. Scratch work if you want to upload any scratch work, and study materials are all up here. Any questions before I move on to the actual study guide? Okay, seeing none, let us look at the study guide. So this is the exact same PDF that is currently posted up on Canvas. So here's the details. Technically speaking, anything we've covered during the semester is fair game on the final, but realistically, that's not going to happen. So roughly speaking, here's the topics. In terms of where we're looking in the course, we're looking in chapters 1. And remember, chapters 1 was a lot of foundational stuff like naming conventions. Chapter 2, which is where we were solving our first-order differential equations. So this is stuff like separable equations, linear equations, exact equations. Section 3 right here, I forget what section 3.1 and 2 were. I believe those were Newton's method and mixture problems is where your book put them. Chapter 4, this was our higher order stuff. So this was homogeneous differential equations, then our method of undetermined coefficients, then our method of variation of parameters. And lastly there in chapter 7, that's all the current stuff we're doing, all of our Laplace transform stuff. All right. What else? Well, that's something that probably doesn't need to be put in there. If this was a paper version, I would say, hey, calculators are okay, but don't go crazy. I don't have a way of. I'm not going to even bother policing in terms of calculators. Most of this stuff you won't need a calculator for, but if you want a calculator, that's fine. What I typically do when I set up the tests, I believe I've done this for both test 2 and test 3, although I don't know how it looks on your guys' end. They actually set it up when I attach the respondus part to the Canvas quiz or to the test. There's a button you can click that says allow calculator. And it basically, there's a built-in calculator somewhere. Now, where it is, I don't know. But what I'll do is I'll go ahead and select that option as well, so that somewhere there's a built-in calculator that you guys will be able to access. I'm sure there's probably something near the top side or bottom of the screen that has something like file option, something, and it's got to be in there somewhere. If I find out exactly where it is, I'll share that with you guys on our page that deals with final exam stuff. The final exam is sort of cumulative, and here's where that sort of comes in. In terms of what we've had for tests 1 through 3, we've had all of the topics we've covered except for one of the big ones we've actually been building towards. And that big topic that we've been building towards is using initial value problems, or having an initial value problem, having a differential equation, and solving it using Laplace transforms. So one of the things you will definitely see in this upcoming final exam is you'll have probably 2, or if I break them up into parts, maybe more questions that talk about you have some initial value problem and you're using Laplace transform to solve it. If this was a paper version of the test, I would just give you 2 initial value problems and a big blank piece of paper that says go solve them using Laplace transforms. To be fair, I'll give you like part A, do this, part B, do this, just so I can find your answers easier. But in terms of the online format, it would be similar to what you guys have seen for like test 3 when you were asked to solve your undetermined coefficient question, where it walked you through the different pieces and you had blocks that you had to fill in. Or like on test 2 where we had the exact equation and it had all the formulas and you had to fill in those pieces and parts. Okay? So it'll be something along those lines, not quite as walking through like WebWork does, where it just asks you for the final answer. Okay? That way you can get partial credit. So what does that mean that you want to make sure that you can do? Make sure that you can compute the Laplace transform of, let me actually highlight these guys, big thing. Make sure you know this. Make sure you can actually compute the Laplace transform of derivatives. Typically on a final exam, I'll give a second order differential equation to use Laplace transforms with, but if it's something that's nice that's a third order, you could see a third order as well. And also make sure you can handle what happens if you actually have a t, one of your independent variables, multiplied by this guy. So we actually did one of those examples, I think the last example that we did last time, and it's also one of them is on your homework question. What happens is if you have a independent variable right here, you're actually going to get, as you work through the entire solution, you'll have, when you transform it into the Laplace transforms, you've built a little secondary differential equation. That secondary differential equation will be either linear or separable. And when I say or, it's really and or. They all should be linear, and some of them are also separable. You then have to solve that differential equation. You get what your Laplace transform is. Then you want the original guy, so you take the inverse Laplace transform. If you have one of these guys, it would definitely walk you through it, and at most you would have one of them. The other thing that you want to make sure that you can handle, and I don't see it written down here explicitly, so let me go ahead and type it in here as well. We also dealt with discontinuous functions. So we had an example of a initial value problem that we solved using Laplace transforms, where I believe it was the non-homogeneous part, the part on the other side of the equals, was one of these step functions. Okay, so that's something that you might see as well. So that would be something you should definitely expect to see, and I would definitely expect, if it's a full, complete differential equation to work, expect to see 2 of them. If it's not the full problem, if it's only pieces and parts of it, like for example, on some of your WebWork questions, it says here's your differential equation, solve for the Laplace transform of y, or that capital Y of x. That's only like a third of the problem. Okay. If you have something in parts like that, there might be more than 2 questions. Now, in terms of our prior topics that we've had, so these are the topics that you would see from like what we had back in test 1, 2, and 3. Some of the big things, and these totally are some of the big topics that you need to know going out of this course and going into your future classes. So assuming that you guys are going to use this stuff in the future, and if you are any of the majors of engineering, physics, math, and depending what brand of computer science, some of the computer science guys, you're going to be using some, if not all of this stuff. By far, the way that most differential equations courses are taught or phrased is really more focused towards the physics, mechanical engineering areas, but the same sort of stuff works in more of the computer science, computer engineering areas as well. We skipped those examples this semester, though. So in terms of the highlights of what you need to make sure you know, you want to make sure you can handle separable equations. Remember, separable equations are what? They're first-order differential equations. So what you're looking at is where you can have your derivative. And I know when we were in first order, we pretty much never said y prime. I'm going to do that because my stylus, its battery died on Monday during class. Super fun. I do not recommend. And everywhere I called has no batteries for it. It's amazing. So I don't get batteries until Friday. So I'm typing. It's going to be amazing today. So it'd be something like this. You're looking for these guys. So hopefully this is readable enough. Trust me, trying to do this freehand did not work well when I tested it earlier. So that's separable. You're just looking to see if, hey, you can factor it out into the two separate variables. Remember what that meant. Make sure you actually write this first part as what you really want that thing to be. And let me put it actually out front here. You really wanted that to be like a dy over d. Wow, that didn't work at all. Let us undo that. That was too close. Let's try it again. Dy over dx. It's typically how you want to do it because y, you separate the dy and the dx to various parts. Separable equations is actually why we didn't use the primes way back when in first order. Now the other one that you want to make sure that you can handle are linear first order differential equations. In terms of questions that you could see, you'll probably see, I would definitely recommend, assuming that you'll see a separable differential equation, watch out for things that can factor. You may actually see a linear first order differential equation as well. However, you may also see this guy, and let me go ahead and type the format to remind ourselves. You may also see this guy inside of the Laplace transform thing. And we did what? We did p's. So for example, when we talked about Laplace transforms right up here, when you have the t involved, you had a secondary differential equation. Typically, it's this guy. It's possible that you'll have a Newton's law of heating or cooling question or a mixture problem. So Newton's law or a mixture problem right here. But realistically, those guys are going to be the first ones that go if I start having to delete questions based on time. Okay? But in terms of the things to focus on the most, definitely focus on making sure you can deal with solving differential equations using Laplace transforms. Make sure you can deal with separable and linear differential equations. Could there also be things like these story problems? Sure. If so, I'd walk you through them just like I did in test 1. I believe the last 1 or 2 questions of test 1 would be similar to that. Okay. You might also be asked to solve a homogeneous differential equation using the characteristic equation. You probably won't be asked one of those questions all by itself, although you could. If so, it'd probably be a higher order guy similar to the practice test for test 2. But the big thing that you want to do is you want to make sure that you can handle your non-homogeneous guys. And here you would get that only if you're looking at method of undetermined coefficients and or variation of parameters method. Why? Because if you're using Laplace transform, you don't have to grab your homogeneous solution and your particular solution and add them together. It's all done at once. So those would be sort of the big highlights in terms of both new topics with the Laplace transforms and the older topics. Now, in terms of things that are missing here, all of these guys are talking about solving differential equations. There are some extra things you have to worry about. One of the extra things that you have to worry about is knowing your Laplace transforms or your inverse Laplace transforms. So in terms of format, here are some things that so let me actually add that right here. Don't forget. So this is like the extra things you need to do the other ones. Make sure you're comfortable with your Laplace transforms. Your inverse Laplace transforms. Apparently I can't spell Laplace today. Also, you need to be comfortable with dealing with your Wronskian. Why? Because if you can't deal with a Wronskian, what happens? You won't be able to deal with variation of parameters because the formula has the Wronskian in it. And remember what the Wronskian does. The Wronskian, if it equals 0, and I'm going to do the equal 0 version as opposed to the not equal 0, which is what we actually want. If the Wronskian equals 0, this tells you that your functions that you use to build your Wronskian are linearly dependent, which is exactly opposite of what you want when you're building solutions. So maybe you have some sort of question that asks you to compute the Wronskian of maybe 2 or 3 functions, and then it says, hey, were these functions linearly independent or dependent? You check to see if the Wronskian equals 0. If it equals 0, you'd say they're dependent. If it doesn't equal 0, you say they're independent. And maybe there's a follow-up question that says something to the effect of, could these guys be viable solutions to build your homogeneous differential equation? Not that. To build your homogeneous solution. Well, if they're linearly independent, the answer is sure. You could build a homogeneous solution here, assuming however many functions you have, let's say 3, assuming it's a third-order differential equation, you pick 3 linearly independent functions that are solutions. Bam, you put them together, you find your homogeneous thing. If you have where the Wronskian equals 0, you've got functions that can be written in terms of the other or linearly dependent, and then you wouldn't want to use all of them if you're building your homogeneous solution, because homogeneous needs to have linearly independent solution. So there's a question that came in that said, will there be numerical problems? When you say numerical, do you mean initial value problems where we have the initial conditions? Like y of 0 equals 0, y prime of 0 equals 3? Or are you thinking more of things like Euler's method and Runge-Kutta or RK? Okay. So the question is, are we going to have anybody dealing with Euler's method or Taylor method or improved Euler's method or the Runge-Kutta method? And the answer to that is no, I'm not planning to. Is it something that is used tons and tons outside of this class? Yes, they're actually really frequently used. However, we did all the questions that I would be comfortable putting on a timed exam back in test 2, and most of you guys did really well on it, so I'm not planning on doing them again. So this one is really, if you want to think about it in terms of what you would expect to see, think of this exam being more of, you got a bunch of different differential equations that you would want to solve. And you would then decide what method to use and how to do it. And that would be 100% accurate if we were on paper. The format would be a little bit different here just so that you can get partial credit and easier to enter the answers. So let's get into formatting. So I broke this up into 2 parts. I'm not going to claim that we'll actually have 2 parts, although we might. Okay? So types of questions that you could see. I will probably put this at the beginning of the exam. Some things that are more theory-esque questions. So maybe they would be something like, well, like what we just talked about. If you're told, maybe you're told something as simple as y1 equals blank, y2 equals something else. I don't know. So maybe like y1 equals e to the t, and y2 equals just plain old t. And you're told that their Wronskian equals whatever their Wronskian equals. I'm going to pretend it's 4. It's definitely not 4, but let's pretend. Okay? So if you're told the Wronskian of those 2 guys is 4, well, what can you conclude? Well, 4 is not 0, so that means the 2 functions are linearly independent. And maybe you're told a second piece of information. Maybe you're told y1 equals e to the t and y2 equals t are both solutions to some differential equation, and you're given the differential equation. So then the question would be, hey, what's the homogeneous solution? Well, what would you do? You could just add those 2 functions together, put c's in front of them. Or maybe you're asked, is there another function that's also a solution that's linearly independent to these 2 guys? The answer would be no, because the maximum linearly independent solutions is the same as the order of the differential equation. So in other words, maybe some sort of theory question of how do you put together a solution? Or maybe that same question is phrased in a crazy different way. Maybe it says something like, here's a differential equation, maybe it's order 5, something that I would never really ask you to solve unless it was really easy to factor. Maybe this order 5 guy that's crazy difficult to actually figure out. And it'd say something like, how many solutions to its homogeneous differential equation should you be looking for? Well, if it's order 5, you would be hoping to get 5 roots out of your characteristic equation. You don't necessarily know what they are, but you'd be looking for 5 roots. And then you need 1 solution that corresponds to each of those roots. So that would mean you'd be looking for 5 linearly independent solutions, specifically for the associated homogeneous differential equation. Okay, so that might be something going on. Notice in terms of all of those guys, all of them are things that you have to do anyway. If you were solving a differential equations, it's just sort of asking you, what is your thinking process? Why are you doing the step that you're doing in this method? Maybe you have something that's similar to one of your quizzes that was dealing with superposition. Maybe you have something where you're told, this guy is a solution to the associated homogeneous guy, this next function's a solution to the homogeneous guy, and this third function's a solution of the non-homogeneous guy. Well, how do you find the general solution of the non-homogeneous? Add all 3 together. Don't forget coefficients on these solutions to the homogeneous. Okay, so that would be some of those theory-esque questions. So make sure I don't miss anything. So in terms of how the questions would be worded, things like fill in the blanks. We've seen that lots and lots when we've been online. Short answer, this would be something in Canvas it's called an essay question, where it would be me asking you to write like a sentence of describing what you would do. Those type of questions in Canvas have to be graded by hand. So if you happen to have one of them, at the end of the exam when it gives you your score, there would be a little asterisk that says, hey, I still have to go grade something. So if the question was worth, say, 5 points, everybody would not yet have whatever percentage of those 5 points that you'd actually get back for your answer. Just as a heads up, because sometimes that freaks people out. Might talk about definitions. What else? It might actually be multiple choice. Which one of these works as a format? This one you probably won't get, but make sure you know your Laplace transforms. That way you can use them later on. And maybe instead of asking you to fully solve a story problem, maybe it just asks you to set up the differential equation that corresponds to that story problem. Or maybe there's the multiple choice. Which of these differential equations corresponds to the given story problem? Now, the second part was what we were focusing on the topics up here. This is something where you have just several differential equations. Typically, in the past, I've given about 5. It's normally 4 or 5, depending on how easy or hard they are. And some of them you might be told what method to use. Some of them you might not be told what method to use. If you're not told what method to use, this would probably be some sort of matching problem in an online format where you would have to decide, hey, is this guy separable? Is this guy linear? Do I have to use Laplace transforms here? Could I use variation of parameters here? That sort of thing. Otherwise, you'll probably need to be told what method to use, and then it'll actually walk you through with basically fill in the pieces of what you would need to do at each step. But that would be the idea here. And then in terms of sample questions, we had a bunch of various quizzes, some in class, some online. The various homework sets, all of the solutions, save the last 2 homework sets, should be posted now, so you can go back and look at them. I went ahead and, I can't remember if it was last night or early today, and made it so that you, if you wanted to, could turn in the last 2 homework sets essentially up to the final exam time. So if you want extra time on those last 2 guys, you can. They would also be really good study guides because they're dealing with how to solve differential equations using Laplace transforms. The other thing that is not mentioned on here, and let me add it in, is looking over your old tests. The other thing is looking over the old practice test. And while these guys are not visible or accessible right now, I mentioned at the beginning of our time together that I was going to go and convert it so you could go back and access any of your old practice tests, and if you wanted to go back through them and take them multiple times, you totally can. For the old test, I'll make it, you should have your test 1, but for your test 2 and 3, I'll make it so you can see what you got right or wrong on those guys. I think that's almost everything. The only other note I have here to myself is, no, that's for me for writing practice test, because I'm still in the middle of transforming it from handwritten to online. Okay? So that's basically what I had planned for today, is to go over what you would expect to see. Here's the theory questions, here's the computational questions. The only other type of question that I have been considering, so this would be not really a part 3, but I'll go ahead and write part 3 here, is something where it might be a file upload question. We tried doing this in our practice test 2 and found that it didn't work when respondus was attached to the test. So if I have this occur, where I ask you to write out either on paper or electronically, however you want to, some question, it would most likely be some differential equation, and maybe it would be one that's both separable and linear, and you get to pick which way. Or maybe it would actually be one of these guys where it's asking you to solve the initial value problem using a Laplace transform. Right now it's a 50-50 shot of whether you've got one of these guys or not, just because I really don't want to grade them. And having to deal with one extra level of complexity of making sure you don't forget to do that file upload, especially if you have an issue of uploading a file, is also a consideration. So it's possible that you might have one question where you're asked to upload a file to it. If that happens, let me show you where that would occur. So if that occurs, when you're looking at your Canvas page, and this is the one that says Final Exam, Details and Information, right here would be the button for the final exam, and probably between it and the button right here that says Scratch Work would be some button that says question. If it's say question 3, it'd say something like question 3, and that would be where you would upload your file for that question. And like I said, right now it's 50-50 shot of whether it's happening. I can see pros and cons of both ways, and I haven't decided which way we're going to do or not yet. Any questions from you guys? All right, I'm not seeing anything come in. So that was it that I had in mind, or it in terms of what I planned for in terms of going over stuff for the final exam. The links for the old practice exams will go up soon. The link for the practice final exam is probably going to take a little bit longer in coming. I am currently shooting, what day is today? Today's Wednesday. I am currently shooting to try to get it up tomorrow night is my current plan. And that is mainly because one of my other classes, I've got a little bit of an issue I've got to deal with later tonight, and I suspect it's going to take about 4 hours to finish. Still not seeing any questions from you guys. All right. Well, if you guys don't have any questions, that is all I've got for us.